so you grew up in a Christian
Yeah.
home, and you're now obviously part of our church and a kind of professional adult
Yeah.
scientist. Can you just tell us a little bit about how you sort of ended up calling yourself a Christian now as an adult?
Yeah, so my mum's Christian, my dad's not, but we always went to church and was very involved in a Christian charity called the Girls Brigade. So went through that, and I think it was just the input of loads of adults sharing the gospel throughout my childhood that really cemented it as a personal belief for me. And then that continued with some great adults in university, and then when I first moved to London, going to a great Bible believing church.
Cool, wonderful. And you have told me before your job title, and I can only remember one of the words, which was consultant. Can
Yeah.
you tell us what your job is, and what you enjoy about it and what you don't enjoy so much?
So I'm a consultant pediatric and perinatal histopathologist at St George's, which in simple terms means I spend most of my time either doing postmortems or examining placentas to determine why miscarriages or stillbirths have happened, to answer those questions for parents. Um, I enjoy the detective nature of it because usually they come with very little clues as to why it's happened. It's been a quite sudden, distressing event. And you really do need to answer some questions for them, or at least listed a load of things that it isn't for future planning. Probably the least favorite job or aspect is probably as I was saying, the NHS management that you don't get as a trainee, but you get because it takes you away from doing your job. It takes you away from answering those questions, dealing with all the issues that come up in big picture NHS terms.
Yeah. Well, that's a warning to all the medical students that we have. Just beware. Well, thank you for sharing that. And so we're thinking about this topic tonight: evolution, why it doesn't disprove God, and I imagine that's the kind of thing that would come up quite often with scientists. And so if a colleague asked you that, what would you be able to say, sort of maybe from your own personal experience or your own thoughts on that question?
Yeah, I think I'd point them back to what we do. So most of you, the general population, are able to examine nature creation on a very macroscopic level. We have the privilege of being able to look at an organ, the cells, in the most microscopic details, thousands and thousands of times with some of our equipment, more than the naked eye could see. And each bit of that cell has to work in perfect harmony for the cell to have its function. On a physical level, I can hold the smallest of hearts that weighs less than a gram, and it's still perfectly formed, and it still functions. And I say to them that I can't see how that isn't intelligently and purposely created, that something has to be so organized on so many tiny details for it to function as it should do without causing major problems.
Wow. That's an amazing insight that you get into those things. Very enviable. Well, thank you for sharing a bit of your experience, Millie. It's been lovely to hear from you this evening. And obviously when church gets back to slightly more normal, then people can chat to you more freely. But thanks for sharing this evening. Really appreciate it. Well, let me welcome Professor Richard Buggs once again. And Richard, we're really glad to have you back. You came a little while ago, I think during the first lockdown it was. How's life?
Yes, that's right.
Then?
Well, thanks for having me again. And it sounds like you don't really need me to come and speak to you. You've got Millie who can do just as good a job as I can. And all I'm going to do really is amplify a few things that she's already said.
Great. Well, thank you for joining us. And again, Richard, you've got one of those job titles that I can only understand about a quarter of it. So could you just, for those again who haven't come across you before, just tell us what you do and maybe a bit of background, how you ended up doing it.
Well, my university job title is Professor of Evolutionary Genomics. And evolutionary genomics is looking at whole genomes. So a gene is a small segment of DNA, but a genome is all of the DNA in our cells. So for the organisms I study most, which are ash trees, the genome size is 880 million letters of DNA. So we're sequencing that large body of information and then trying to understand it. And what we're doing, especially with an evolutionary approach, is looking at differences between individuals and between species to try to understand what we can learn from those differences. So in a nutshell, that's what evolutionary genomics is.
All right, lovely. And just tell us what you enjoy doing when you're not thinking about evolutionary genomics and ash trees.
Well, again, management is is the big distraction that can get a bit frustrating. What I really enjoy is just thinking about things and writing about science. And thankfully now I don't have to spend much time in the lab. I can spend most of my time writing grants and writing papers. So I've loved my job more and more the further on I've got in it.
Good to hear it. Well done for all the hard graft that's got you to where you are now.
It's a bit boring at times.
Well, I'll give you the floor, Richard. Thank you so much for joining us this evening.
Well, thanks very much. So what I want to argue tonight is not that evolution doesn't happen, but that evolution doesn't disprove God. And many atheists wouldn't put it quite that strongly. They wouldn't say evolution disproves God, but they might say evolution makes a big contribution to the credibility of atheism. So, for example, Richard Dawkins, the very well-known Oxford atheist, wrote in his book, The Blind Watchmaker, that Darwin made it possible to be an intellectually fulfilled atheist. And so we have to ask, well, why is it that Darwin is claimed to make it possible to be an intellectually fulfilled atheist? And to understand why there was a problem for atheism before Darwin, we have to think about our thought processes that happen when we see something very complex like the heart of a tiny baby. For example, a couple of weeks ago, as you know, it snowed reasonably heavily for London. And on Sunday, 2 weeks ago, I went for a walk in Kew Gardens. And there I saw a snowman. And I didn't think for a moment that that snowman had just come about by flakes of snow just happening to fall into the particular pattern of the snowman, and then the odd cone and twig blowing into place by a gust of wind to form its eyes and its nose. I immediately thought, well, there's been an intelligence at work here. A human being has made this snowman. They've planned out in their head what they're going to do, and they've pushed the snow together to make the snowman. And as I looked around, there were lots and lots of snowmen in Kew Gardens, all slightly different. And I could see different levels of ability of snowman making. But for all of them, I immediately inferred this was the result of intelligent activity of a human being. And if you'd been with me and I had tried to argue with you that no, this wasn't due to intelligence, but it was just the way the flakes happened to fall, it was just really chance plus gravity plus the melting point of water that caused these shapes to come about, you would say, no, you're crazy not to think that these were planned intelligently. And imagine that we hadn't been in Kew Gardens. Imagine we'd been on an island in the Arctic that we had, until that point, assumed was not inhabited. We'd assumed that there were only a few animals on this island, and then we came across a snowman. Well, we might look slightly more closely than I looked at those snowmen in Kew Gardens, but if we saw a snowman, we would immediately say, well, there must be human beings here. We wouldn't say, even if we thought that the island had been uninhabited before, we would immediately assume it was inhabited because this snowman was there and it must be the result of an intelligence. And so down through history, people have taken that argument and applied it to the biological world, and they've said, look at how complex life is. Look at how complex a human heart is. Look at how complex a hand is. Look at a flower. These things are so complex. they must be the result of intelligent activity. The Greek philosopher Socrates would look at a statue and he'd say, look, we look at that stone statue and we immediately infer that must have been designed, and we admire the handiwork of the artist who made that statue. How much more when we look at the human body do we infer the work of an amazing intelligence who has an eye for beauty and detail and complexity. And down through the ages, that has struck just about everyone as a very powerful argument for the existence of a powerful superintelligence, otherwise known as God. And before Darwin, the only recourse anyone who wanted to be an atheist had was to say, well, this must have just been chance. And not many people found that convincing, not surprisingly. I mean, if we couldn't even imagine a snowman coming about by chance, how much less could a human body just be a chance concatenation of atoms? So atheism seemed pretty much impossible. Very, very few people dared to be an atheist because the intellectual case just wasn't there. But then Dawkins says Darwin came along, and since Darwin, it became possible to be an intellectually fulfilled atheist. Well, why is that? Well, he says Darwin gets rid of this problem of huge amounts of luck. Darwin gives us a way of explaining biological complexity without needing massive, massive chance happenings. And well, how does that work? Well, the Darwinian process, Dawkins says, breaks down the production of complex entities in life into small steps. And each step needs a bit of luck, but not so much luck as to make it impossible. And it allows these small steps to gradually accumulate until we build up complexity. Let me give you a little visual example of that, just to help get the point across. Imagine I walked into my living room in the morning, and on the floor was this perfect circle of a Brio train track, maybe with a little train sitting on the top. And I know that I didn't make it. I know my son didn't make it. I know my wife didn't make it. And there are two possible explanations. One is that the toy box fell over, and by chance, each of those bits of Brio fell into place to make that perfect circle. The other alternative is that someone has been in our flat and they have put those pieces together into a train track. Now, I think my wife would probably think I was quite crazy if I said, well, I think they just fell out of the box like that. I mean, it's not as improbable as a snowman, but still pretty improbable that that should happen. How would the Darwinian mechanism help us? Well, the Darwinian mechanism would say, well, instead of one sudden step that was very improbable, putting all 8 pieces in place, imagine if we have a process by which that Brio just keeps falling out of the toy box. And each time it falls out is like a generation, because of course, unlike a snowman, real human beings reproduce. And so reproduction gives us chances to reshuffle the genetic information. And let's imagine with this example of our Brio that we keep having these generations where we shuffle them up. Well, every so often, it's credible that a couple of pieces would join together. Now let's imagine there's something scrutinizing what's happening and saying, if 2 pieces join together, then keep them together. Don't shuffle them up, just retain them. Now, bear in mind, for the Darwinian process, that can't be a conscious agent. It can't be an intelligence. It can't be something with foresight. It just has to be a blind process that just says, that's a bit longer, so keep it. Then we have more and more shuffling, more of these generations, and then eventually, perhaps after many generations, a third bit would get added. And so on and so forth, until eventually we form a perfect circle. And let's imagine that perfect circles are seen by this blind process as being better than something with just ends. So a loop is better than just a track that doesn't loop. Well, we could imagine how that circle could then form and then be retained over the generations, and then perhaps further complexity could build up on top of that. That's the Darwinian process of natural selection. You have random mutation, which is the chance coming together of the different bits of track, sometimes joining and sometimes not in our little example. And then natural selection is that blind process that says retain anything that is slightly better. Now, Richard Dawkins makes it sound as if this process is something that eliminates vast quantities of luck, and that natural selection doesn't really rely on luck at all, it just relies on very negligible amounts of luck. He describes natural selection as being the opposite of luck. And so he makes it sound as if this process of Darwinian evolution is just so inevitable that it will just happen, and life will just inevitably evolve and grow more complex without any oversight, any guidance, any intelligence behind it. And so we can explain complex things like human beings purely by that process. He makes it sound very credible and very obvious that that would happen. But I want to ask the question, does that process really eliminate as much luck as Richard Dawkins says that it does? Does it really allow us to explain life in all its complexity without recourse to an intelligence? And I don't think it does. I think Richard Dawkins massively overstates the reduction in luck that the Darwinian mechanism gives him. Now, no, I'm not saying Darwinian mechanism doesn't happen. We're seeing the Darwinian mechanism at work at the moment in the COVID-19 virus. We're seeing these mutations and these changes, and occasionally we get a strain of the virus that seems to be better at transmitting, and it transmits further and it spreads faster. That's the Darwinian process. I'm not saying that doesn't happen. What I'm saying is it's not adequate to explain complex life without needing to invoke vast, vast amounts of luck that are so vast that it just makes the whole thing unbelievable. So let me go back to my analogy of the train track. Well, of course, a great deal of luck is needed in bits coming together in the first place to join one another. And then we have to remember things don't always join so that they gradually form a more complex circle. What would actually happen in any random process where these were joining together is the sort of train track that my 3-year-old son builds. His train tracks don't have any sort of end in mind, so they just tend to wander around across the floor, and they never make a loop, because making a loop actually involves quite a bit of foresight, and it's not always easy. I can tell you, as a parent who has to make loops, it's not always easy to make a long train track that has a loop. You have to think quite hard about it. And so a random process would just send these sort of squiggly lines across the floor. A lot of chance would be needed to actually get 8 of them coming round into a loop. But then imagine we do get a loop. So we have our nice loop, and natural selection likes that because loops are good. Now, how can I build something more complex? Let's imagine I've got this loop. Sorry, I'm just trying to pick it up, but it's not cooperating. I've got this nice loop. In order to get something more complex, I need a junction. But to get a junction into this loop, I've got to take out one of the other pieces and pop the junction in. But that's a backward step. Natural selection is saying, no, keep that loop, keep that loop. I've got to go backwards before I can go forwards. And the only way that can happen is by chance. Chance has to allow that to happen. Imagine that in my train track, I needed a bridge. Now, to get a nice complex train track, quite often you need one of these bridges, and they consist of 3 pieces. I'm sure many of you are familiar with these. Well, if by chance one of these bits of bridge ends up in my train track, here it is. Once I've got that piece, I can't just have any old piece randomly coming in. If that piece then comes in, I don't get a good train track. Once I've got this piece, I'm committed, so that I then, to have anything functional coming out, I then need this piece. And once I've got this piece, I then need the other little ramp in order to complete that. So I need those three things all to fall in place at once. Now, just imagine the improbability of random shuffling of this train track causing these three pieces all to come in place one after the other. And it's very hard to imagine that you could build complex structures like a cell or like a human body without sometimes needing several places all to fall into place at once before we can have something that's functional. And so as we look at the Darwinian process, and this is very well known to evolutionary biologists, and this surely must be well known to Richard Dawkins as well, huge amounts of luck are needed to generate complex things by the Darwinian process. And when we start to consider some of the nanotechnology that's present in our cells, we see tiny molecular machines of absolutely staggering complexity. It becomes very hard to imagine that vast amounts of luck would not be needed for those to be explained by any process that didn't involve some kind of intelligent input from someone who knew what they wanted this structure to do and what they wanted it to look like in order for it to be able to be produced. Really, we're left back where people were left before Darwin, in having to invoke massive amounts of luck, despite Darwin's amazing insights into life. And I don't really need to belabor this point. I could go on for quite a long time talking about how much luck is needed in the Darwinian process, and all of the different chance events that can interfere with it. But in some ways, I don't really need to do that, because in his book, The God Delusion, Richard Dawkins talks about a few steps in the coming about of life forms that demand vast amounts of luck. One of those steps is the origin of life. The Darwinian process relies on there being reproduction. You have to have generation following generation. You have to start with a replicating machine. To get a replicating machine, though, is itself incredibly difficult. But that can't have evolved in a Darwinian fashion, because Darwinian evolution doesn't work until you get a replicator. And Dawkins is quite commendably quite frank and open about this. He says, the origin of life could have been, we can allow it to have been an extremely improbable event, many orders of magnitude more improbable than most people realize. So he's very clear that he needs vast amounts of luck to explain the origin of life. He then talks about the origin of the eukaryotic cell, which is a kind of cell that we have, which has different compartments within it. It has a nucleus for the DNA, and things like that. He says that could have been an even more momentous, difficult, and statistically improbable step than the origin of life. He then says the origin of consciousness might be another major gap whose bridging was of the same order of improbability. So he's falling back on pure luck in order to explain some of the major transitions that he needs to have happened in order for life and complex conscious life to have come about. And so essentially he's falling back on the only arguments that were available even before Darwin, the invocation of massive amounts of luck. And to my mind, this causes his whole argument to break down. His argument for atheism is Darwin gave us something that enables us to remove our reliance on luck as atheists. But then he has to bring the luck back in order to explain things like the origin of life and the origin of consciousness and the eukaryotic cell. And that's on top of all the luck that's needed in the Darwinian process that he's a bit, that he tries, I think, to sweep under the carpet. Now, if we then step back and think, well, what was the situation before Darwin in terms of the amount of luck that was available to them? And many of the early atheists thought that the universe was infinite, and they thought that it was also infinitely old. And so when they said, well, we need a lot of luck, they could say, well, as the universe is infinitely large and infinitely old, there are just so many opportunities for these things to arise. And so for us to be on the one planet where all of these things happen to be is just believable once we consider that the universe is infinitely large. Our, if you like, our probabilistic resources are absolutely huge, to put it in modern language. But Dawkins doesn't have those huge probabilistic resources, because we know today that the universe is finite and that the universe had a beginning. So he doesn't have the same number of opportunities for these things to happen as they had then. And so to my mind, the argument today for atheism is even weaker than it was back before Darwin. Someone like Dawkins is still having to invoke huge amounts of chance, unbelievable amounts of chance, to explain complex life. And that's what he was trying to get away from, but he's still stuck with that. And so to my mind, the power of that intuition that we all have, that when we see something complex like a snowman, or something like a Brio train set with some nice loops in it and a few bridges, when we see something like a human being or a flower, that intuition that we have that there must have been an intelligent agent who had a purpose and a design here, that intuition is still, as far as I can see, a very respectable intuition, a very logical one, and one which has great explanatory power and is actually much more believable than a mixture of massive amounts of luck plus the Darwinian process of natural selection. And so to my mind, Darwin hasn't made it credible to be an atheist today. It's still a leap of faith in blind luck to be an atheist today.